Problem 55, Quantum Mechanics. The question is, if psi NLM denotes the eigenfunction of the Hamiltonian with a potential V is equal to V of R, then the expectation value of the operator Lx square plus Ly square in the state psi is. Here psi is given. We have to find out the expectation value of the operator Lx square plus Ly square, which is equal to the expectation value of L square minus the expectation value of Lz square. First, let us check whether the given wave function is normalized or not. Take the inner product of psi with itself. This is equal to 9 by 25 plus 1 by 25 plus 15 by 25. This is equal to 1. Therefore, we can say that the given wave function psi is normalized. First, let us find out what is the expectation value of L square. Expectation value of L square in the given state psi is psi L square psi. So first let us find out what is L square psi. This is equal to 3 by 5 L square psi 211 plus 1 by 5 L square psi 210 minus root of 15 by 5 L square psi 21 minus 1. When L square operates on Lm, we will get L into L plus 1 h bar square Lm. Therefore, L square psi is 3 by 5 2 h bar square psi 211 plus 1 by 5 2 h bar square psi 210 minus root 15 by 5 2 h bar square psi 21 minus 1. Now we can write it as 2 h bar square into 3 by 5 psi 211 plus 1 by 5 psi 210 minus root 15 by 5 psi 21 minus 1. This is equal to 2 h bar square psi. Now what is the expectation value of L square? This is the inner product of psi with L square psi. We can write it as psi 2 h bar square psi, that is equal to 2 h bar square, the inner product of psi with itself. We have seen that the inner product of psi with itself is 1. Therefore, the expectation value of L square is nothing but 2 h bar square. Thus, we have evaluated the expectation value of L square as 2 h bar square. Now, let us find out what is the expectation value of Lz square. The expectation value of Lz square in the state psi is psi Lz square psi. So first let us find out what is Lz square psi. This is equal to Lz square 3 by 5 psi 211 plus 1 by 5 Lz square psi 210 minus root 15 by 5 Lz square psi 21 minus 1. When Lz square operates on Lm, we will get m square h bar square Lm. Hence, Lz square psi is 3 by 5 1 h bar square psi 211 plus 1 by 5 0 h bar square psi 210 minus root 15 by 5 h bar square psi 21 minus 1. This is equal to 3 by 5 h bar square psi 211 minus root 15 by 5 h bar square psi 21 minus 1. Now what is the expectation value of Lz square? It is the inner product of psi with Lz square psi. So first let us write what is bra psi. This is 3 by 5 psi 211 plus 1 by 5 psi 210 minus root 15 by 5 psi 21 minus 1. Now take the inner product of this psi with Lz square psi, that is 3 by 5 h bar square psi 211 minus root 15 by 5 h bar square psi 21 minus 1. this is equal to 9 by 25 h bar square, the inner product of side 211 with itself, plus 15 by 25 h bar square, the inner product of side 21 minus 1 with itself, and therefore it is equal to 9 by 25 h bar square plus 15 by 25 h bar square, that is equal to 24 by 25 h bar square. Thus, the expectation value of Lz square is 24 h bar square by 25. Now we can calculate the expectation value of Lx square plus Ly square, that is equal to the expectation value of L square minus the expectation value of Lz square. Expectation value of Lx square plus Ly square is expectation value of L square minus expectation value of Lz square, that is equal to 2h bar square minus 24 h bar square by 25, that is equal to 26 h bar square by 25. Therefore option D is correct.